Welcome to the 6th Annual Prism Awards for Photonics Innovation. One of the common threads that weave all of us together in this room is a respect for, and in most cases, a serious quest for innovation. SPIE and Photonics Media are delighted to recognize some of the most innovative new products and the companies that build them tonight. Life sciences and biophotonics are some of the most significant applications in our field. And the last Prism Award tonight is presented by someone who epitomizes innovation. Before his work as one of the leaders of Google Glass, he made headlines in 2009 for building a prototype bionic contact lens infused with microcircuitry. He has also worked at putting displays into contact lenses. His work has been selected twice as the Invention of the Year by Time magazine. Even more importantly, he has contributed many papers to the SPIE Digital Library and also chaired conferences and written articles for SPIE journals. But it was the development of a project recently in the news pertaining to healthcare that was really quite remarkable. Smart contact lenses for diabetics that measure glucose levels in tears using a tiny wireless chip and miniaturized glucose sensor. In his work, he's pushed between electrical engineering and biology at the University of Michigan and at Harvard, and in between was a device designer and product manager for integrated optical switches before teaching in Seattle at the University of Washington and as associate director of the Microscale Life Sciences Center there. Obviously, his time in Silicon Valley is yielding incredible work, and we are really delighted to have for the Prism Awards in Life Sciences and Biophotonics, please welcome Babak Parvik.
Good evening. This is truly a privilege and an honor to be here this evening with you and presenting the last category, a category that's very close to my heart in life sciences and biophotonics. Over the past few decades, I believe a revolution has happened, primarily through your genius work and with cooperation from commercial forces. You've been able to make incredibly sophisticated photonics and electronic technology available to the broader public at a very affordable cost. I remember actually even as recently as yesterday, I was having coffee with a colleague at the sidebars of Photonics West, and he was mentioning that he's buying a particular type of LEDs, now the chips for 1 cent each. And when you think about how much science has gone into that chip, how much engineering, how much effort in manufacturing has gone into this, and this extremely sophisticated component is available at a cent, you begin to grasp what the opportunities are that lie ahead of us if we apply these technologies into other fields. And it's of particular interest to me and many of my colleagues to apply these to biology and medicine. We have 3 very innovative companies nominated this year for the award, and as you see their work, you would see that they are showing the way to the future. They have done very creative, very innovative work, and they've applied hard sciences and high tech in biology, nanoscale, engineering, and medicine. So let's see what the nominees are.
Most people in the world have a cell phone, but very few have a microscope. Thus, Holomic was born to bring microscopy and health diagnostics to everybody.
With SITE, we aim to make look once, stick once a reality for patients with hard-to-find veins.
It can be used to make better drugs, characterize new nanomaterials, and assess the toxicity of nanoparticles in living systems.
Okay, and the winner is AccuVein.
much for this award. It's, you know, I feel doubly honored tonight, both for winning such a prestigious award, as well as being fortunate to lead a great engineering team in the development of this product. It's a small team, and they worked very hard. They're very intelligent, but yet, you know, there's a lot of work that goes into product design. And I also respect all the other companies that built products this year. And as I said, we're very fortunate to win this award, and I feel very fortunate, as I said, to lead such a great engineering team. An engineering team that is a very respectful engineering team. And I say that because I was given an email this morning from one of my engineers who sent me an email of a picture taken in 1934 from one of these popular science magazines that were very popular in the 30s that showed a picture of veins. And he sent me this picture, and I said, oh, that's very nice, you know, that this has been around a very long time. But I said, you know, we've got this wonderful product. I'm going to be coming to this show and possibly winning an award. And he said, yes, but they did this in 1934. And I said, yes, but we built this wonderful augmented reality product. We're showing this wonderful technology, the ability to see through the skin, see in real time. We do a very low latency display, so it's just like you can look through the skin and see the veins. He said, yes, but they did it in 1934. And I said, well, not only is the product a great engineering product, but it's a successful healthcare product. It's in 3,000 hospitals worldwide. We've helped thousands of people. We've given, you know, one of our sort of internal lines is one prick's enough. He responded by saying, yes, but they did it in 1934. I said, well, then he went on to say, yes, and not only did they do it in 1934, they didn't use lasers, they didn't do electronics. And at that point, I gave up and said, you win. But anyway, thank you very much.
We want to see photonics at work in the world, improving lives, improving manufacturing. We're in a globe of limited resources. We have energy issues. We have health issues. Photonics can contribute greatly to improving the world. SPIE tries really to connect the researchers with the problems. You tonight are innovators who have brought the research forward into products that will end up in the hands of people in factories, improving manufacturing, that will end up in the hands of healthcare specialists, improving health, that will end up in research labs, understanding and beating back disease. We thank you for that.